Boss, and since I couldn't be there today, I figured I would make a little video just to go over the things that you needed to learn today. Okay, so welcome to biology. Today is a B day, October 11th. Um, you have me, Miss Abbas, and if this is 1B, you have Mr. Smith, and if this is 4B, you have Dr. Ahmed there along to help you or to review any information with you. Okay, so we are going to continue to create and look at the atomic models of elements, and we will go over ions in this video as well as covalent bonding. Make sure you go back and review your notes in order to help you understand things better. Okay, so let's look at this molecule of lactose. We notice that it has carbon and hydrogen, oxygen as well. So this is a carbohydrate. We can tell because we have carbon, hydrogen, and oxygen. So why are these elements coming together in just this way? These elements come together in order to become stable. So carbon and hydrogen will share their electrons in order to be stable. Elements are stable when they have the 8 valence electrons. We need to remember that valence electrons are the electrons that can be found on the outer shell of an atom, and we'll look at that some more. So before we get into ions, let's take a quick look at this activity that we did in class the other day. Okay, so we have sodium. The atomic number for sodium is 11. So that tells us how many protons we have. So we should know, oops, let me clear that out. So we should know that we have 11 protons. You're going to have to excuse me, it's not easy writing with this mouse. The atomic mass of uh, sodium is 23. So we take 23 minus 11, and that gives us 12 for our neutron number. And then we know our electrons are always equal to our protons. So we have 11 electrons. If we were to draw our Lewis dot structure, we would have Na, which represents our sodium, and then we have one dot on the outside. Remember, I just said that sodium, as well as every other element on the periodic table, wants to be stable. So if we plot out our sodium atom, we'd have 2 electrons on the first level because every element can hold 2 electrons in the first level only. Every level outside of that first level can hold 8 electrons. So I'm just going to draw 8 electrons. I'm just going to use lines instead because it's hard to do the dots. So I'm going to draw the 8 electrons onto this circle. So now I have 8 plus that 2, that is equal to 10, which means I need one more energy level. And I'm going to add an electron to this level. So if we count up our electrons now, we can see we have 11 electrons. Okay, so remember every element wants 8 electrons on its valence shell. Sodium only has 1 electron. In order to resolve this, sodium can give that electron away. So sodium with its 1 electron, I'll use an X, will give that electron away to another element. This makes sodium an ion. So now we have 11 protons, 12 neutrons. So in this case, the number of protons doesn't change. The number of protons will never change. The number of neutrons doesn't change. But now we have one less electron because sodium gave that away. So we have 10 electrons. What we will do now is take the number of protons minus the number of electrons, and that will show us what the charge is on our sodium ion. So we have 11 protons minus 10 electrons, and that is equal to a positive 1. So our ion with its symbol and charge is sodium, with a positive charge of 1. So plus 1. So were electrons lost or gained? In this case, electrons are gained. How many? One electron was gained. And that makes it a cation. So the way I remember is cations have more letters than anion. So anything that has a positive charge would be a cation. Anything with a negative charge will be an anion. And again, it's really not related to the name. I just think of cation as being positive because it has more numbers. Okay, so I'm just going to look at the protons and electron numbers for oxygen. Proton, oxygen has 8 protons, it has 8 neutrons, and it has 8 electrons. So oxygen has a valence of 6 electrons. In this case, it is much easier for oxygen to gain electrons. The other way we know it's going to gain is because it is a nonmetal. We know that oxygen is a gas. So the nonmetals will gain electrons and our metals will lose electrons. So we need 2 more electrons here. So we would have 8 protons, 8 neutrons, and since we are adding electrons, we would have 2 more electrons giving us 10 electrons. I do my math. 8 minus 10, which gives us a value of negative 2. Okay, so when I write my symbol, and then I write my charge of negative 2. Because it is a negative charge, we know that would be an anion. And I'm sorry, I made a mistake here. I wrote that we were gaining electrons in this first one, and we did not gain any electrons. We lost those electrons there. Here we gained electrons. That's why we have the negative charge. We gained 2 electrons, so we have an anion. I hope that makes sense. Oh, I made that little mistake, but hopefully when we look at this next example, we can fix it. Aluminum has 13 protons, if I remember correctly, 14 neutrons. 13 protons and means that it will atomically also have 13 electrons. Aluminum is a metal, just like aluminum foil. So that metal is going to lose its electrons. We can also tell that it's going to lose the electrons because there's only 3 electrons on its valence shell. It'll be easier to give those 3 electrons away than try to find 5 more to fill its valence shell. So here I'm going to draw my aluminum, Al, draw my dots around the outside, and then draw how those electrons are going to be given away. So my aluminum here is losing its 3 electrons. Again, my proton and neutron number stays the same. But since I lost 3 electrons, I take this 13 and subtract 3, and that gives me 10. So electrons are lost. 3 electrons are lost. And that gives me a net positive charge. So it makes it a cation. How do I know it's a positive charge? I take 13, the number of protons, minus 10, and that's equal to positive 3. So here I will write my ion symbol, which is Al. And then my positive 3 charge. So hopefully after watching this video, you can answer the next 3. On the back side, if you flip over, you should have the 3 ions of magnesium or chlorine, magnesium, and sulfur. Remember, cations have a positive charge, anions have a negative charge. So let's look at why these ions are important. Again, atoms are only stable when they have 8 valence electrons. Atoms can become stable by donating or accepting electrons. This creates what's known as an ion. Ionic bonds happen between metals and nonmetals. So remember, the metals will donate their electrons to a nonmetal. So the metals will become cations, and the nonmetals, like oxygen, will become anions. Anions gain an electron and become negatively charged. Cations lose an electron and become positively charged. Ionic bonding happens when the 2 oppositely charged elements are attracted to each other. So sodium will give its electron to chlorine, each becoming more stable and each being attracted to each other. Table salt is an example of an ionic bond. Sodium chloride is table salt. Some of you are familiar with Epsom salt. Epsom salt is magnesium chloride, and it works very much the same way, where magnesium will donate its 2 electrons to chlorine. So 2 chlorines plus 1 magnesium gives us magnesium chloride. The other type of bonds that you need to be familiar with is the covalent bond. Covalent bonds, I believe, are much easier to understand. There are three possible types of covalent bonds: a single covalent bond, a double covalent bond, and a triple covalent bond. Also, with the goal of completing the valence level. Before we get to the bonds, let's look at a shortcut for knowing how many valence electrons there are. Here, we're just going to ignore this middle section that's blue, and we're going to focus on groups 1, 2, 13, 14, 15, 16, and 17, and 18. It's very simple. The number of electrons is the same as the group number. So group number 1 includes hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. All of these elements have one electron in their valence shell. Group 2, which includes beryllium, magnesium, calcium, strontium, barium, and radium, all have two valence electrons. Again, we're going to skip these transition metals that are this light color of blue and bounce over to group 13. Group 13, 14, 15, 16, 17, and 18. For all of these, we would subtract 10. So if we subtract 10 from 13, we end up with the number 3. So boron, aluminum, gallium, indium, titanium all have 3 valence electrons. Carbon, silicon, germanium have 4. Nitrogen, phosphorus, arsenic have 5. Oxygen, sulfur, and selenium have 6. Fluorine, chlorine, bromine, and iodine have 7. And the last column here all have 8. These are known as noble gases. These gases will never donate their electrons, nor will they accept electrons or even share electrons. They are stable on their own, having the perfect octet or 8 electrons in their valence level. So let's do some practice with covalent bonding. When we look at this worksheet, we can easily identify hydrogen as having 1 electron. How do we know it has 1 valence electron? Simply look at our model here. It is in group 1, 1 valence electron. Now we are going to look at fluorine. Fluorine is in group 17. That means it has 7 valence electrons. I'm going to use an X for my 1 hydrogen, and I'll use dots for my fluorine. Remembering fluorine has 1, 2, 3, 4, 5, 6, 7. Let me just make this dot here a little bit darker. So now I want to show that 1 hydrogen is sharing its electron with 1 fluorine. I draw the H with an X. Then I draw my fluorine with its dots. One, 2, 3, 4, 5, 6, 7. There is one exception to the octet rule. or two exceptions actually, and that's hydrogen. Hydrogen only needs two electrons to be stable. Because hydrogen only has one electron, that means it only needs to fill that first valence shell. Remember, the maximum in that first valence shell is 2. Now let's look at nitrogen. Nitrogen is in group 15. That means it has 5 valence electrons. Chlorine is in group 17. That means it has 7 valence electrons. Let's go ahead and draw that out. Here's our nitrogen with 5. 1, 2, 3, 4, 5. So we can see we only have one paired electron set here, and chlorine has 7. 1, 2, 3, 4, 5, 6, 7. Here's where it gets a little tricky. On your worksheet, you should see that this says NCl, so nitrogen chloride with 3 chlorines attached. How do we do those 3 chlorines? I'm going to make my nitrogen here with my X's. And then I will attach my chlorines. There's a chlorine here. 2, 3, 4, 5, 6, 7. There's a chlorine on this side. 1, 2, 3, 4, 5, 6, 7. And then a chlorine on this side. 1, 2, 3, 4, 5, 6, 7. So we can see that was a little bit of a tricky one. With that, you should be able to do H2. Oxygen is another tricky one. Oxygen exists in our atmosphere as O2. So I'm going to take one oxygen and use X's. If you don't want to use X's and you just want to stick with dots, then you should use two different colors so you can see the difference between each element. So my oxygen has 6. 1, 2, 3, 4, 5, 6. Again, it's kind of hard using this mouse pad. And this one also has 6. So 1, 2, 3, 4, 5, 6. So this one is a little tricky because remember, they can share one pair of electrons, two pairs of electrons, or even 3 pairs of electrons. Oxygen needs 2 electrons each, so oxygen forms a double bond. So I'm going to put 2 electrons here. Oh, this one will be X's. And 2 electrons here at the bottom. And then the oxygen will form double bonds. So I will put 2 electrons here in the middle for my oxygen on the left. Then this oxygen will have its 2 dots at the top, 2 dots at the bottom, and then 2 dots in the middle. So here and here. So this oxygen is forming its double bonds here in the middle, sharing 2 sets of electrons. Here, this is a single bond. So go ahead and try number 4 and number 5 on your own. Hint, we have 4 hydrogen. This is methane gas. And here we have 2 oxygen and a carbon. So these are going to be a double bonds down here. These are going to be a single bond. If you want, you can move on and try N2. Remember, nitrogen needs 3, so this is going to be a triple bond, so that's even trickier. And again, you can see by sharing electrons, our element becomes stable. A covalent bond is much stronger than an ionic bond. Think about how easily salt dissolves in water. Salt dissolves very easily in water because it's an ionic bond. Sugar requires a little bit more in order to dissolve in water because it is a covalent bond. That brings us to this end of this video. I know it's kind of long. Pause as you needs to. You can also rewatch later. Mr. Smith and Dr. Ahmed are also there to help you as needed.